Let us consider a quadratic equation x square plus 9 is equal to 0. If you try to solve this equation, you know it very well, x square will be equal to minus 9. And if you want to find the value of x, just take square root on both sides. Square root of x square is equal to square root of minus 9. So square root of x square will be equal to minus 1 into 9. Now the problem arises. For example, if you see the square root of minus 9, you cannot take square root for the number minus 9 in real number cases. For example, if I ask you to find the square root of 9, you can say the answer is plus or minus 3. If you say plus 3 into plus 3 is equal to 9. If you say minus 3 into minus 3 is equal to same plus 9. But you will never get this minus 9 by squaring a number. So here the problem comes. Here the complex number arises. So the minus 9 is written as minus 1 into 9. Now it is considered that minus 1 as equal to I square. This is the key concept of complex numbers. So if you replace this minus 1 by I square, you will be getting square root of x square is equal to I square into 9 inside the square root. So if you take square root for this, it is very simple. So x is equal to plus or minus 3i. So here we are not simply using the real works. We are imagining something, that is minus 1 is imagined as I square, and we are getting this solution. So these type of numbers are called complex numbers. For example, if you are not solving x square plus 9 is equal to 0, instead of solving x square plus 9 is equal to 0, if you try to solve some other quadratic equation, for example, you know very well ax square plus bx plus c is equal to 0 is a quadratic equation where a is not equal to 0. So if you try to solve this equation, you know very well from the 10th standard itself, the solution for this quadratic equation is x is equal to minus b plus or minus root of b square minus 4ac by 2a. Listen here carefully. In case if this value or the value which comes for b square minus 4ac is a negative 1, automatically it will raise to a complex number. So if you consider the general form of a complex number, while solving an equation, you may be getting a minus b by 2a plus or minus root of b square minus 4ac by 2a. That is minus b by 2a will be a real answer. But in case inside the root if we get a negative number, surely we cannot get answer for this in real way. So we are imagining something, that is minus 1 is equal to I square. So here minus b by 2a will give you a real value, but this root of b square minus 4ac by 2a will be giving you a imaginary value. So the complex number can be written in this form. That is, we are getting perfectly by not considering any imagination, that is minus b by 2a is our x part. So inside our square root if we get a negative number, we are getting I, and for b square, but for the square root of b square minus 4ac by 2a we are getting y. So simply if you are talking about a complex number can be in the form x plus iy, and it is represented by the letter z. Now z is a complex number, x is real part, y is imaginary part, but both x and y belongs to real numbers, right? So now you know what is a complex number. So if you want to compare the real number with the complex number, what do you mean by a real number? real number can be represented on a line, that you know very well. Just like you can represent a real number on a line. It may be a integer, a natural number or a whole number, or irrational number. Everything can be represented on a line very easily. Similarly, here you can compare two numbers, that is -1 is less than 0, or you can say 2 is greater than 1. Like this you can compare two numbers. But in complex number it cannot be so. See here. Listen here carefully. A complex number is in the form z is equal to x plus iy. So we need two axes. One represents the real axis and another one represents the imaginary axis. So I need two axes to represent a complex number. Just like real number, we cannot represent a complex number on a line. We can represent a complex number only on a plane. This plane is called by the name Argand plane. So our complex number now becomes a point. We cannot say this point is greater than that point or that point is lesser than this point. So for a complex number, surely we cannot say, for example, let us consider two complex numbers z1 and z2. You cannot say z1 is greater than or z2 or z1 is less than z2. Simply, for example, if two complex numbers are located in the same place, we can say z1 is equal to z2, and if they are not located on the same plane, same place, we can say z1 is not equal to z2. This is a short note on complex number. Let us see in deep what is a complex number, how it operates, other things in our next class. Thank you.